Okay, students, let's start with the past papers of electricity. Today we are going to see MCQs related to electricity. So let's start with the first MCQ. A radioactive source produces a beam of alpha particles in a vacuum. The average current caused by the alpha particles is this. Perfect. The beam is incident on a metal target. What is the average number of alpha particles hitting the metal target in a time of 3 seconds? First of all, utilizing the current and utilizing the time, you can calculate the charge. Yes, current is equals to charge over time. Current into time will be equal to your charge. Perfect. What is your current? 1.5 into 10 raised to the power of minus 9. What is your time? That is 3. What does your charge come out to be? 4.5 into 10 raised to the power of minus 9 coulombs. This is your charge. Now you don't have to calculate the charge. Instead, you have to tell the number of alpha particles incident on the metal target. So each alpha particle has two protons. What is the charge on two protons? 2 into 1.6 into 10 raised to the power of minus 19. This comes out to be what? 3.2 into 10 raised to the power of minus 19 coulombs. Okay. So if each alpha particle has a charge of this, how many alpha particles will have a charge of 4.9 into 10 raised to the power of minus 9? Let's do that. One alpha particle has a charge of 3.2 into 10 raised to the power of minus 19. How many alpha particles will be required to generate a charge of 4.9 into 10 raised to the power of minus 9? Let's place an x here. 4.5 into 10 raised to the power of minus 9, and let's divide this entire thing by 3.2 into 10 raised to the power of minus 19. Your answer comes out to be number of alpha particles are 1.4 into 10 raised to the power of 10. C should be your answer. The answer to this question should be C. This is question number 1. Let's check out. Yes, the answer to 1 is C. Perfect. Let's further move ahead. A fine mist of oil droplets is sprayed into air. Perfect. As the oil droplets leave the nozzle of the spraying device, they can become electrically charged. Perfect. What is not a possible value for the charge on an oil droplet? Okay. Always remember, charges are quantized. Always remember, charges are quantized. Charges are quantized. Sir, what do you mean by that? Charges are quantized. This means that charges will be in the multiples of 1.6 into 10 raised to the power of minus 19. 1.6, then 3.2, then 4.8, then 6.4, then 8.0, and obviously 10 raised to the power of minus 19 is applicable in all of them. So charges are quantized. That means they are multiples of 1.6 into 10 raised to the power of minus 19. 0, yes, 0 can be a charge. It can be a neutral thing, yes. C can also be a charge because it is a multiple of 1.6. D can also be a charge because it is a multiple of 1.6. Which on which option cannot be a multiple of 1.6? B. That is 1 into 10 raised to the power of minus 19 coulombs. Let's further move ahead. Okay, let's move on to this question. The electric current in a wire is 4 milliampere. Perfect. The electric current in the wire is 4 milliampere. How many electrons pass a fixed point in the wire in a time of 10 hours? Perfect. So the current is 10 milliampere, time is 10 hours. What will be the charge? Charge is equals to current into time. What is your current? 4 milliampere, 4 into 10 raised to the power of minus 3 multiplied by the time of 10 hours, that is 10 into 60 minutes into 60 seconds in each minute. Can we calculate this charge? Yes, we can surely do that. This charge comes out to be 4 into 10 raised to the power of minus 3 multiplied by 10 multiplied by 3600, which is 144 coulombs. This is 144 coulombs. Each electron has a charge of what? Each electron or one electron has a charge of what? 1.6 into 10 raised to the power of minus 19 coulombs. 144 coulombs का charge will be on how many electrons? X cross multiply it. 144 divided by 1.6 into 10 is the power of minus 19. This comes out to be what? Answer divided by 1.6 into 10 is the power of minus 19. This comes out to be 9 into 10 is the power of 20. Let's further move ahead. Let's see this. A metal wire is connected between the terminals of a cell so that there is current in the wire. Which statement is correct? Negatively charged electrons in the wire move from the negative terminal, yes, to the positive terminal. This is the correct statement. Electrons move from the negative to the positive terminal. Let's further move ahead. A wire carries a current of 0.1 microampere. The potential difference across the wire is this. How much energy is dissipated by the wire in a time of 10 seconds? So we have to calculate work done. Voltage is equals to work done over charge. What is your voltage? 10 millivolts. 10 into 10 is the power of minus 3 multiplied by the charge. Actually, we don't have the charge, but we have current and time. Charge is equals to current into time. What is your current? 0.1 into 10 is the power of minus 6. Your time is what? 10 seconds. What does your work done come out to be? Let's calculate that. 10 into 10 is the power of minus 3 multiplied by 0.1 into 10 is the power of minus 6 and multiplied by 10. This gives you an answer of 1 into 10 is the power of minus 8 joules is equals to your work done. We have a decimal here. Let's take this decimal one place forward. 10 into 10 raised to the power of minus 9 joules is equals to your work done. What is 10 raised to the power of minus 9? It is nano. Work done comes out to be 10 nano joules. D is your answer. Let's further move ahead. A nichrome wire has a resistance of 15 ohms, diameter of this. The number density of free electrons is this. This is your N. A potential difference is this. Okay, what is the drift velocity of the free electrons? What is the formula of drift velocity? Drift velocity is equals to current over NaE. That is the charge of the electron. How can you calculate the current? V is equals to IR. What is your voltage? 6 divided by the resistance, that is 15. 6 divided by 15, this comes out to be what? 0.4 ampere as your current. Perfect. Your current is 0.4. What is the number density of electrons? 9 into 10 raised to the power of 28. Can you calculate the area as well? Yes. Diameter is 3 millimeter. Area is equals to what? Pi over 4 du square. Let's calculate that. Pi over 4 into diameter, that is 3 millimeter. 3 into 10 raised to the power of minus 3 whole square. Perfect. Anything else that is left? Yes, the charge of the electron. The charge of the electron is equals to what? 1.6 into 10 raised to the power of minus 19. Let's calculate the final answer. Answer divided by 9, 8, 10 raised to the power of minus 20, no, 10 raised to the power of 28 into pi divided by 4 into 3 into 10 raised to the power of minus 3 and take a whole square here. Perfect. Into 1.6 into 10 raised to the power of minus 19. The answer comes out to be what? 3.9. The answer for drift velocity comes out to be 3.9 into 10 raised to the power of minus 6 ms minus 1. B should be your answer. This is question number 6. Let me check in the marking scheme. The answer is B. Yes. Let's further move ahead. Okay, so let's see this question. A power supply is connected to a component by connecting wires of total resistance 4.9 ohms. The power supply has an output power of 3.6 volts and a terminal potential difference of 12 volts. Perfect. How much thermal energy is wasted in the connecting wires in a time of 1 hour? Okay. So first of all, are you given the power output? Yes. Are you given the voltage? Can you calculate the current using both of these? Yes. Power is equals to IV. 3.6 divided by voltage, that is 12. This comes out to be 0.3 ampere as your current. Now you have the current, and the same current will be in the connecting leads of 4.9 ohms. Can you calculate the energy? Yes. I square R into time. What is I? 0.3 square into resistance. That is what? The resistance of the resistance wire is 4.9. What is the time? 1 hour, 60 minutes multiplied by 60 seconds. Let's calculate this answer. Zero point 0.3 square into 49 to 3600. This comes out to be 1.6 kilojoules. 1.6 kilojoules is your answer. Simple as that, nothing complicated here. Let's see this. The diagram shows a metal block. Perfect. The block has side lengths A, B, and C as shown, and its volume is V. Perfect. The volume of the block is V. Perfect. Each charge carrier has a charge of Q. The number density of the charge carriers is N. It takes each charge carrier an average time of t to pass through the block. You have to calculate an expression for current. Do you remember that current used to be equal to what? NAQV. What is the area? On which area is the current incident? On this area, this highlighted area. This area will be equal to what? A into C. So let's replace it. N multiplied by A into C. Perfect. How can you replace the velocity? How can you replace the velocity? Yes. How can you replace this variable of velocity since you are not given the velocity directly here? The electron will travel this much of length, that is equals to h, in a time of t. I think time was given. Where was the time? Yeah, here it is. Time was given. So velocity can be replaced by what? Distance over time. Distance traveled is h, time is t, multiplied by h over t. Can you realize A into C into h will be equal to what? The volume of the object. NQ, volume of the object divided by time, is your current. B is your answer. Let's further move ahead. The circuit diagram shows two lamps X and Y, each connected to a cell. Perfect. The current in lamp X is this, and it has a resistance of this. The current in lamp Y is this, and it has a resistance of this. Perfect. What is the ratio of power in lamp X divided by the power in lamp Y? Power in lamp X divided by the power in lamp Y. How will we calculate that? Current in X square multiplied by the resistance X. Current in Y square multiplied by the resistance Y. What is the current in X? 0.5 square. What is the resistance? 9.6. Divided by the current in Y, that is 3 square. Multiplied by the resistance, that is 1.5. Your answer comes out to be 2 over 9, that is 0.22. A is your answer. Let me check. The answer to 10, if we see here, is A. Perfect. This question is number 10. The answer to 10 is A. Let's further move ahead. The number of free electrons passing a point in a wire in 24 hours is this. Perfect. What is the average current in the wire? We have to calculate the average current. Current is equals to charge over time. Perfect. These much electrons are passing. So what will be the charge? Each electron carries a charge of what? 1.6 into 10 raised to the power of minus 19 divided by the time, that is 24 hours. 24 into 60 minutes in each hour into 60 seconds in each minute. Let's calculate this. 6 into 10 raised to the power of 6 into 10 raised to the power of 10 raised to the power of 23 multiplied by 1.6 into 10 raised to the power of minus 19. Perfect. Divided by 24 into 60 into 60. The answer comes out to be 1.1 ampere. B is your answer. The answer to 11 in marking scheme is B as well. Let's further move ahead. A wedge-shaped metal conductor of length L, varying width and uniform thickness, is connected to a cell as shown. Perfect. So as you are going from point X to L, your area is increasing. Perfect. Which graph best shows how the drift velocity V of the current, V of the electrons in the conductor varies with the distance x from end x. Perfect. So we have to tell how the velocity is varying as the area is increasing. We have studied that drift velocity is equals to current over NAQ. Can you realize that drift velocity and area are inversely proportional? Can you realize drift velocity and area are inversely proportional? A will be your answer. Simple as that. Let's further move ahead. Okay, so let's see this question. A wire has a length of 12 centimeter and contains a total of how many electrons? 5.1 into 10 is the power of 22. Perfect. When a potential difference is applied across the ends of the wire, the free electrons move with a drift velocity of this. Perfect. You have to calculate the current in the wire. You have to calculate the current I in the wire. So first of all, we know that current I is equals to what? NAQ V. Perfect. Now, if you have studied drift velocity in detail, you know this n. This small n is what? Number of electrons per unit volume. Number of electrons per unit volume. So what can you do here? You can say capital N over volume. Capital N is the total number of electrons divided by the volume is equals to your small n, that is the number of electrons per unit volume. Perfect. Area can be represented how? We know volume is equals to area into length. Volume over length must be equal to area. So let's replace area with what? Volume over length. Multiplied by the charge, multiplied by a small v, that is the drift velocity. VV cancel out. What is the total number of electrons? 5.1 into 10 raised to the power of 22. Divided by length, that is 12 centimeters, 0.12. Multiplied by charge, that is 1.6 into 10 raised to the power of minus 19. Multiplied by the velocity, that is 4 into 10 raised to the power of minus 6. Your current comes out to be 0.27 ampere. C is your answer. Let's further move ahead. 4-point charges, each of charge q, perfect, are placed on the edge of an insulating disk of radius r, perfect. The disk rotates at a rate of n revolutions per minute, perfect. So there are n revolutions per unit time, perfect. What is the equivalent electric current at the edge of the disk? Perfect. Current is equals to what? Charge over time. You have four charges, 4q, and the number of revolutions per unit second is n. The total current is equals to 4q. Na is your answer. Let's further move ahead. Okay, so let's look at this question. Free electrons flow along a copper wire X. Perfect. The copper wire X has a radius of this with an average drift speed of this and a current of this. Perfect. Now let's highlight the next things in yellow. There is a current of 2 ampere in copper wire Y of radius this. First and foremost thing, what have I always told you? Whenever there are too many variables or too many numeric things given in the examination, it is better to form columns. Your wire X has a radius of what? Radius of 5 into 10 raised to the power of minus 5 meters. Average drift speed of what? 2.8 into 10 raised to the power of minus 2. Perfect. Ms minus 1. Perfect. The current is 3 amperes. What will be your number of free electrons in wire X? Can you calculate the number of free electrons in wire X? Yes. I is equals to NAQV. I have to calculate this N. I have to calculate this N. This N will be equal to what? Current over AQV. Perfect. Let's shift this column of Y more towards the right. Somewhere here. Perfect. What is the current in the circuit? What is the current in copper wire X? 3 ampere. What is the area? Pi over. Okay, so we won't do pi over 4. There are two formulas for area. One is pi r square. If radius is given, use this formula. If diameter is given, use this formula. Here we are given the radius, we will use the first formula. Pi into 5 into 10 is the power of minus 2 whole square. This is your pi r square multiplied by the, I think I will have to further move it towards the right. Let's move it somewhere here. Multiplied by 1.6 into 10 raised to the power of minus 19. And what is your drift velocity? 2.8 into 10 raised to the power of minus 2. So further multiplied by 2.8 into 10 raised to the power of minus 2. Let's calculate the number of free electrons here. 3 divided by pi, 1 second, 3 divided by pi into 5 into 10 raised to the power of minus 5 whole square into 1.6 into 10 raised to the power of minus 19 multiplied by 2.8 into 10 raised to the power of minus 2. Your number of free electrons come out to be 8.52, or you can say 8.53 into 10 raised to the power of 28. Now please remember, if the material of the wire is same, if the material of the wire is same, can you see wire X is also made of copper, wire Y is also made of copper. So the number of free electrons in both will also remain same. Y will also have how many electrons? 8.53 into 10 raised to the power of 28. Perfect. Your current is what? 2 ampere. Perfect. Your radius is what? 1 into 10 raised to the power of minus 4 meters. Perfect. Can you calculate the drift velocity here? Yes. Drift velocity is equals to current over NAQ. What is your current? 2 divided by the number of free electrons, 8.53. 10 raised to the power of 28. Now let's zoom in a bit. I think I am short on space here. Your area will come out to be what? Pi into the radius square, that is 1 into 10 raised to the power of minus 4 whole square. Charge is 1.6 into 10 raised to the power of minus 19. Let's calculate this answer. 2 divided by answer into pi into 1 into 10 raised to the power of minus 4. Take a whole square here and then multiply it by what? Multiply it by 1.6 into 10 raised to the power of minus 19. This answer comes out to be 4.6. The answer for velocity comes out to be 4.6 10 raised to the power of minus 3 ms minus 1. So that is equivalent or more closest to option number A. The answer to 16 in the marking scheme is also A. We have correctly calculated this. Let's further move ahead. Okay, let's see this. Two resistors R1 and R2 are made from wire of the same material. Again, what does this means? What does the wire from the same material means? This one will also have n number of electrons per unit volume. This one will also have n number of electrons per unit volume. The diameter of R2, okay, the diameter of R2 is half of R1. Perfect. That means R2 can have a diameter of D. This can have a diameter of 2D. Perfect. The resistance of R2 is 3 times the resistance of R1. Perfect. The resistance of R2 is 3 times the resistance of R1. So let's say this is 3R and this will have a resistance of R. You have to calculate the ratio of drift velocities. Perfect. To calculate the ratio of drift velocity, first of all, let's calculate the drift velocity for resistance 1. The current in 1 divided by what? Number of free electrons, n, divided by the area. What will be the area if your diameter is twice? Your area will become 4 times. So 4A into the charge. Perfect. Can you calculate the drift velocity for resistor 2? Yes. Current of 2, current in the resistor 2 divided by n divided by area divided by charge. Let's divide both of them. V1 upon V2. This will come out to be what? I1 over N4A Q divided by I2 NAQ. Is anything getting cancelled out? Yes. NAQ. NAQ gets cancelled out. Only 4 is left here. Only 4 is left here. Perfect. So what will your ratio actually become? I1 over 4 I2. But there are no options like that. You have to somehow substitute I1 over I2 as well. Now here you need to remember one very simple point. Resistance is inversely proportional to current. Can you calculate the resistance ratios Can you calculate R1 over R2? Yes. R1 over R2 is what? R over 3R. R and R cancel out. It is 1 over 3. If R1 over R2 is 1 over 3, what will be I1 over I2? What will be the current ratio? 3 over 1. So you can replace this I1 over I2 with what? 3. 3 over 4 is your answer. Is there any options like that? B is your answer. The answer to 17 should be B, and B it is. Let's further move ahead. Let's see this as well. In an electrolyte, the electric current is carried by charged particles, ions in solution. What is not a possible value for the charge on an ion in solution? Perfect. What have I told you? Charges always flow in the multiple of 1.6 into 10 raised to the power of minus 19, 3.2, 4.8, 6.4, 8.0. Any of these values which is not a multiple of 1.6 into 10 raised to the power of minus 19. This is a multiple, this is also a multiple, this is also a multiple, this is not, hence D will be your answer. What is a possible charge on a particle? Again, you have to see which one of them is a multiple of 1.6 into 10 raised to the power of minus 19. 1.6, 3.2, 4.8, 6.4. Any answers? This cannot be your answer, because if you divide it by 1.6 into 10 raised to the power of minus 19, you get a non-integer value. Very easy method to do it. If you divide this as well by 1.6 into 10 raised to the power of minus 19, you get a non-integer value. If you divide this by 1.6 into 10 raised to the power of minus 19, you get an integer value, and that integer value is equals to 7. C is your answer. Let's further move ahead. The current in the circuit is this. Perfect. What is the direction of flow and rate of flow of electrons through the resistor? Okay. What is the direction of flow of electrons? Always remember, electrons flow from a negative terminal to a positive terminal. Electrons flow from a negative terminal to a positive terminal. So they will flow from Y to X. A and B options will get cancelled out. Perfect. The current is what? 3.2 milliampere. Perfect. Can you calculate the rate of flow? Yes, yes, yes. If the current is 3.2 milliampere, what will be the charge transferred in 1 second? Current into time. 3.2 into 10 raised to the power of minus 3 multiplied by 1. This comes out to be 3.2 into 10 raised to the power of minus 3 coulombs. Simple. This is your charge transferred in 1 second. Okay. One electron carries a charge of what? 1.6 into 10 raised to the power of minus 19. A charge of 3.2 into 10 raised to the power of minus 3 will be carried by how many electrons? X. Let's calculate this answer. 3.2 into 10 raised to the power of minus 3 divided by 1.6 into 10 raised to the power of minus 19. Your answer comes out to be 2 into 10 raised to the power of 16. C is your answer. What are the definitions of potential difference and electromotive force in terms of energy transfer, work done, and charge? Both of them can be represented as what? Work done over charge. And if I am correct, the answer to 35 should be A. I hope I am correct. Yeah, the answer to 35 is A. Let's further move ahead. Okay, let's see this question. In the circuit shown, the battery has an electromotive force of 6 volts and negligible internal resistance. 3 resistors each have resistance R. Perfect. The total power dissipated in the resistor network is this. What is the value of R? First of all, can you resolve these resistor network? Yes, this will remain R. The second branch will become 2R because both of them are connected in series. Can you calculate the total resistance here? Yes, 1 upon RT is equals to 1 over 2R plus 1 over R. This becomes what? 2 gets multiplied on this side to make the denominators equal. 3 over 2R is equals to your 1 over RT. Perfect. What will your RT become? RT is equals to 2R over 3. Perfect. Now, we also know that power is equals to V square over R. Perfect. Power is what? 24. V is what? 6. Take a square of 6. R is what? 2R over 3. Perfect. Now multiply 3 in the numerator. This becomes what? 24 is equals to 36 into 3 divided by 2. Okay. And this is your R at the bottom. Perfect. So how to calculate R? Very, very easy. Take R to the other side, bring 24 to the denominator. R is equals to 36 into 3 divided by 24 into 2. This becomes 3, this becomes 2. And 9 over 4 should be your answer. 9 divided by 4. 2.25 ohms, that is 2.3 ohms. D is your answer. Let's further move ahead. Okay, let's see this. In the circuit shown, a fixed resistor X is connected in series with a battery and a variable resistor. Perfect. The power dissipated in X is this when a current of 3 ampere passes through it. Perfect. The variable resistor is adjusted so that the power in X increases by 50%. Okay, okay, okay. What is the new current in the circuit? Perfect. What you can do right off the bat is you are given that the power of X is 7.2 volts, current is 3 ampere, power is equals to I square R. Power is what? 7.2. Current is what? 3. Take a square of 3. Your resistance comes out to be what? 7.2 divided by 9. Your resistance comes out to be 0.8 ohms. Perfect. Now the variable resistor is adjusted such that the power increases by 50%. So the new power across X will be what? 7.2 into 1.5. This equals to what? 7.2 into 1.5. This equals to what? 10.8 volts. This equals to what? 10.8 volts. Your resistance will remain same. Can you calculate the current? Yes. Power is equals to I square R. Power is equals to 10.8. Your resistance is 0.8. Take an under root, you will get your current. So 10.8 divided by 0.8. Take an under root. Your answer comes out to be what? 3.7 amperes. B is your answer for 38. In the marking scheme as well, 38 ka answer is B. Let's further move ahead. Let's see this. A cell has a constant electromotive force. Perfect. A variable resistor is connected between the terminals of the cell. Perfect. The resistance of the variable resistor is decreased. What will happen? Current will increase. Perfect. Which statement about the change of cell's terminal potential difference is correct? Okay. As the current is increased, the loss volts or the voltage through the internal resistor will increase. Hence, terminal potential difference will decrease. Terminal potential difference is decreased because more work is done moving unit charge through the internal resistance. A seems to be a very good option. 41. Let me check the answer. 41's answer is A. We are going correct. Let's further move ahead. Okay, let's see this. The power output of an electric supply is 2.4 kilowatts. Okay. At the potential difference of 240 volts. Perfect. The two wires between the supply and a kettle each have a resistance of this. Perfect. As shown. What is the power supplied to the kettle and what is the potential difference across the kettle? Perfect, perfect, perfect. So, first of all, you need to realize that you can calculate the current using these two values. Your power is equals to IV. Power is equals to what? 2.4 into 10 raised to the power of 3 divided by voltage, that is 240. Your current comes out to be what? Let's calculate that. 2.4 into 10 raised to the power of 3 divided by 240. Your current comes out to be 10 ampere. Here as well you will have 10 ampere and here as well you will have 10 ampere. Perfect. Can you calculate the potential difference across the kettle? Yes, 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 yes. We can do that. How? We know that this 0.5 ohm resistor will take how much of voltage? V is equals to IR. Current is 10, 0.5 ohm ka resistor, 5 volts taken away. Same thing will happen with this wire. 5 volts will also be taken away here. What will be the voltage remaining for the kettle? 240 minus 5 minus 5. This comes out to be 230 volts. Perfect. So option B and D will get cancelled out. Okay. Your kettle is getting 230 volts and the current across the kettle will remain same, that is 10 ampere since it is in series. What will the power become? 2.3 kilowatts. A is your answer. Let's further move ahead. Okay, let's see this. This is a very technical question. A cell of electromotive force but with internal resistance is connected to a fixed resistor R using a potentiometer. Perfect. A voltmeter measures the potential difference between the terminals of the cell. Perfect. This voltmeter is measuring what? This is measuring the terminal potential difference. What is terminal potential difference? EMF minus the voltage across the internal resistance. Perfect. Which statement explains the change to the reading of the voltmeter? Okay. As contact Z is moved towards end X of the potentiometer. So, okay. So, if you are moving contact Z towards end X, what is happening? Can you realize if you are moving contact Z towards point X, you are shifting more and more from a parallel combination towards a series combination? Can you realize initially this combination was something along these lines, but now it has shifted to a series combination? So, what do you think will happen? Your resistance will increase. As your resistance increases, what will happen? Your current decreases. As your current decreases, the voltage across the internal resistor, the voltage across the internal resistance IR decreases. As voltage across the internal resistance decreases, EMF remains same, terminal potential difference or the reading on the voltmeter increases. C is your probable option because the current decreases, voltmeter reading increases. Simple as that. Okay, let's see this question. An electric cable consists of 7 strands of copper wire, each of diameter is connected in parallel. The resistivity of copper is this, perfect. The current in the cable is this, perfect. This is in the cable. This current is in the cable. It is getting divided into 7 strands. It is getting divided into 7 strands, perfect. What is the potential difference between 2 points on a cable at a distance of 1 meter apart? Okay. What is the potential difference across 2 points on the cable that are 1 meter apart? So you can say resistance is equals to what? Resistivity L over area. Perfect. Now, what can you further say? You can further say that your resistance is equals to what? V is equals to IR. Voltage over current is equals to your resistance. Perfect. Let's write that as well. Is equals to resistivity L over A. Perfect. Now, you have to find the voltage. You have to find this voltage value. Perfect. Are you given the value of current? Yes, 13 ampere. Perfect. Are you given the value of resistivity? Yes. Are you given the value of length? Yes, 1 meter. Are you given the value of area? No. But you are given the diameter. Can you calculate the area with that? Can you calculate the area with that? Pi over 4 into diameter square into diameter square. Let's calculate this. Zero point 0.3 into 10 raised to the power of minus 3 whole square into pi divided by 4. This comes out to be what? The area comes out to be 7.07 into 10 raised to the power of minus 8 meter square. Now, this is the area for one strand. This is the area for one strand. What will be the area for 7 strands? Multiply this by 7. Okay, so you have to calculate voltage. Voltage is equal to resistivity into length divided by 7A. Why 7A? Because I have multiplied the area of each strand by 7. Okay, what is resistivity? Okay, so let's substitute the values now. Voltage is equal to resistivity, that is 1.72 into 10 raised to the power of minus 8 multiplied by the length, that is 1 meter, multiplied by the current, that is 13 amperes, divided by 7 into the area. Area is what? 7.07 into 10 raised to the power of minus 8. Your voltage comes out to be 0.45 volts. C should be your answer, and C is your answer in the marking scheme as well. Okay, so let's look at this MCQ. This MCQ basically is stating what? This MCQ is stating that a cell of electromotive force E and negligible internal resistance is connected into the circuit as shown perfect. The voltmeter has a very high resistance and reads the potential difference V out. What is the ratio of V out over the electromotive force? First of all, let's draw this circuit correctly. This is your EMF E. This is your 12 ohm resistor. And what further do we have? We have these two resistors connected in series. So 2 ohms and 4 ohms. Okay. Can you realize that the voltmeter is only connected across the 4 ohms resistor? Can you realize that the voltmeter is connected here? Okay. And let's say it is reading a output voltage of V. V out, you can say. Have we studied the voltage divider rule? Have we studied the voltage divider rule? Yes, we have studied the voltage divider rule. In voltage divider rule, what do we used to say? Resistance over the total resistance multiplied by the total voltage is equals to your V output. So your V output of the 4 ohms is already here. What is your total voltage? EMF. The total voltage across this branch will be E or EMF. What is the resistance of the 4 ohm resistor? 4. What is the total resistance in this branch? 4 plus 2, that is 6. Perfect. Divided is equals to your V out. We have to calculate V out over E. So V out over E is equals to 2 over 3D is your answer. Let's further move ahead. Okay, let's look at this question. The diagram shows a circuit. Perfect. Which statement about the circuit is not correct? The electromotive force is energy transfer per unit charge. Yes. Energy is transferred from chemical energy into other forms. Yes. Electromotive force of the cell is greater than the potential terminal potential difference. Yes. When the switch is open, the voltmeter measures the electromotive force of the cell. No. No, 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 no. Let's further move ahead. Three resistors are connected in parallel across a power supply. Let's say the power supply has a voltage of V as shown. What is the power dissipated in each of the resistor 2 ohms, 3 ohms and 4 ohms, P2, P3 and P4 respectively? What is the ratio of P2, P3 and P4? Perfect. So the voltage across the 2 ohm resistor is V. The voltage across the 3 ohm resistor is V. The voltage across the 4 ohm resistor is V. Can I calculate the power across the 2 ohm resistor? Yes, V square over R, that is 2. Can I calculate the power across the 3 ohm resistor? Yes, V square over 3. Can I calculate the power across the 4 ohm resistor? V square over 4. Perfect. Can I calculate the ratios? P power 2 ratio power 3 ratio power 4. Power 2 is what? V square over 2. What is power 3? V square over 3. What is power in the 4 ohm resistor? V square over 4. These all get cancelled out. Now, this is your final scenario. 1 ratio 2 and 1 over 1 over 3, 1 over 2, sorry, ratio 1 over 3, ratio 1 over 4. The most incorrect option in the examination was this. How can you simplify this further? You cannot see any answers here. How can you simplify this further? Take LCM, multiply by 3, multiply by 3, multiply by 4, multiply by 4, multiply by 6, multiply by 6. 6 ratio 4 ratio 3. All of them have a denominator of 12. 12, 12, 12 gets cancelled out. 6 ratio 4 ratio 3. What is your answer? C is your answer. Simple as that. A simple circuit comprises of a source of electromotive force connected to a load. Perfect. How does the output power of the source depend on the internal resistance and the resistance R of the load? Power is equals to what? V square over the total resistance. This total resistance comprises of what? Internal resistance plus the external resistance both. So R is dependent on both small P is dependent on both small r and capital R. If I check the answer to 62, it is D. Yes, it is correct. Let's further move ahead. Okay, let's see this. What is the combined resistance of the network between terminal X and Y? We have to calculate the combined resistance. What can you do? First of all, calculate the resistance of this parallel combination. 1 over 1.2 plus 1 over 4.7 is equals to 1 over RT. This comes out to be what? Let's calculate that. 1 over 1.2 plus 1 over 4.7, 1 divided by answer. This comes out to be 0.955. The combined resistance of this comes out to be what? R parallel comes out to be what? Or R total comes out to be 0.95 kilo ohms. Perfect. Yes. Add this to 2.2 plus 2.2. 2.2. This comes out to be 3.15 ohms. So C is your answer. The combined resistance is the resistance of this parallel plus the series resistance. C is your answer. Let's further move ahead. An electrical cable is made up of one thick strand of copper wire that is surrounded by eight thin strands of copper wire. All nine strands of wire are connected in parallel with each other. A cross section of the wire is shown. Perfect. Each thin strand of the wire has a cross sectional area A, length L. Perfect. Each thick strand of the wire has a cross sectional area of what? 4A and a length of L. The cable has a total resistance R. What is the expression which gives the resistivity of copper? Resistance is equals to resistivity L divided by A. Your resistance is R. What will your area be? 4A plus all these, how many? 8 strands. Your total area will be 4A plus 8A, that is 12A. Perfect. Resistance is equals to resistivity L divided by 12A. 12 AR divided by length is equals to your resistivity. 12 AR. D is your answer. Let me see which question this is. 76. Let's check out the answer to 76. It is D as well. Let's further move ahead. Which graph shows the current versus voltage characteristics of a filament lamp? Always remember the current versus voltage graph for a filament lamp will be a decreasing curve. D is your answer. Let's further move ahead. Let's see this. A copper wire is to be replaced by an aluminum alloy wire of the same length and resistance. Perfect. Copper has half the resistivity of the alloy. Perfect. What is the ratio of the diameter of the alloy wire divided by the copper wire? Perfect. So what you can do here, again create columns, copper wire and alloy. Perfect. A wire is to be replaced of the same length and same resistance. So both of them have the same length, same resistance. Perfect. Copper has half the resistivity. So this becomes half resistivity. This is complete resistivity. You have to calculate the diameter of the alloy wire divided by the diameter of the copper wire. How can you do that? Very, very, very easy. Do you remember the formula of resistance? Resistance is equals to resistivity L over area. Area can be replaced by what? Area can be replaced by pi over 4 d square. Can I make d the subject here? Yes. D square is equals to 4 resistivity L over pi r. This is the formula that we will be using. Okay. For copper, what does your resistance come out to be? Oh, sorry. What does your diameter for copper come out to be? Sorry, my bad. What does the diameter square of copper comes out to be? 4 into half of resistivity, perfect, into the length L divided by pi r. What does the diameter square of alloy comes out to be? Yes, 4 into the resistivity into length divided by pi r. Perfect. Now, what can you do? You can divide both these values. Divide it. Diameter square of alloy divided by diameter square of copper. What is the value of alloy? This one. 4 into resistivity into L pi r divided by what? This becomes 1, this becomes 2. 2 rho, 2 rho L divided by pi r. Pi r cancel out, rho L cancel out. 4 divided by 2 will be your answer. What does your answer come out to be here? Yes. What does your answer come out to be here? Your answer comes out to be 2. But this is the square ratios. This is the diameter square of alloy divided by the diameter square of copper. You have to calculate only diameter ka ratios, not the square ka ratios. So you will take an under root here. Take an under root here. Simple. These will get cancelled out here. Your answer comes out to be under root 2. Let me check the answer. The answer to 80 is, one second. It is A. Yeah, that's correct. This marks the end of past papers for electricity. If you have any questions, you may ask in the comments below.